Okay, it's Go Math, Unit 11, and now we're going to take it one step further. So we have been talking about basically the area of any different object. We started with polygons, we talked about specifically trapezoids, we talked about triangles, we broke it down into pentagons, hexagons, heptagons, nonagons, and so on. So what we're going to do now is take it one step further. So instead of just covering area, and that's the area of a two-dimensional shape, we are going to cover surface area. And the surface area is now taking a two-dimensional shape and we're moving into three dimensions. Eventually what we're going to do is we're going to fill that up, and that's going to be volume. But ultimately what we want to do with surface area is take the shape apart and look at all the surfaces. So it's no longer just one surface, right? We don't have just a triangle, but we might have something that's a bit more of a triangular prism. And then we start taking that apart and we find that it's not just one triangle, but we have triangles and maybe squares, different things to look at. So one thing that I'd like to show you with this, for example, if I start here with a box, and I want to know maybe how much wrapping paper it would take to cover this box. Well, I need to know basically the surface area. So it's not just one particular rectangle. I have a rectangle here, and I have a matching rectangle on the other side. I have rectangular surface on the bottom, and I have a matching rectangular surface on the top. I have a smaller rectangular surface on the side and another one here. So what does that look like? And in order to do that, I have to take my shape, which is very similar to this. So I'm going to show you on paper while I'm showing you with this particular object here. I start with my box. They look kind of alike, right? And realize that in this box, there are also three sides I don't see. I've got three sides that I do, and then hidden in here are three sides that I don't see. Mind those scratches in there, right? So I have this shape. What does that shape look like? Well, I've got the front, I have the top, and I have the side, right? And if I have a front, I also have a back. If I have a top, I also have a bottom. And if I have a left, I also have a right. So front and back, top and bottom, left and right. I only need to know three of these shapes, this one, and the top. If I know the sizes of those, I can solve for the surface area, and then if I take the front, I double it, I also have the back. If I have the left side, I double it, I also have the right side. So what does it look like if I take my shape and break it apart? Well, again, I'm going to start with my overall box here. And what happens if I take this box apart? So this box I have actually already taken apart for you. Once I remove it, I realize that I split it and my sides come open. Now in this particular one I have a top flap and a bottom flap, but if they were all together maybe there would just be one lid. What does it look like when I pull it apart? Surprisingly, there's a number of people out there that can't imagine things that they don't see. So they can't picture things in their mind. If you tell them picture a yellow horse, that doesn't jump into their mind, right? So when I'm looking at this, this is called a net. I've taken that shape and then I imagine myself unfolding it. Well, there's the back, there's the side, there's the front, there's the other side, where's the top and the bottom, right? And this lays out really nicely, so now I can solve for all of my surface area. Again, this one has 4 flaps that break out for the top and the bottom, but I could just have one, maybe, depending on the box, right? So when I've broken it apart, what does that look like on paper? Obviously, you're not going to carry around boxes and all kinds of shapes so that you can take them apart like I just did, but hopefully that helped. If I look at this and I say, okay, well, here's the front. Off of the front, there's the side. Then on the other side would be the back. I'm laying it open, and then I need a fourth side. So now I have all 4 of my sides. What am I missing? I'm missing my top and my bottom. Well, the top and the bottom are probably going to be somewhere like this. Now I have what's called a net. Not a net like you would go fishing with, but it's a three-dimensional net. I've taken a shape that is normally 3 dimensions, and I've broken it apart so that I can see all the different areas. So now if I knew the different sizes, I could solve for the surface area, not just one shape of area, but all 6 sides of the area here. 1, 2, 3, 4, 5, 6. And that's a good rule of thumb when you're checking to see if you have the complete net. How many sides are in this shape? 6. I've got a front, a back, a left, a right, a top, and a bottom. So how many are in my net? 6. I've got a front, a side, a back, a left, a top, and a bottom. If you have all of those, the shape itself matters less and less. It is kind of helpful because you can separate them out. But if I know the different measurements, I can put those measurements in and solve all of this. All right? So what happens if we go to your book, and the first thing that they're going to ask, sorry about that, first thing that they're going to ask is if you had a box that was corn twisties. Well, the corn twisties, I don't know what I would compare them to, but we're working on a layout for a cereal box. Identify the solid figure and draw a net so that the designer can show the placement of information artwork on the box. So they're not going to make a 3-dimensional box and then start drawing on it. They want to lay it out so that the printer can just spit them out, right? So the first thing that I want to start with is my actual shape. There's a 3-dimensional box. Now when I lay out my 3-dimensional box, I realize I'm going to have a front, a side, a back, a side, and a top, and a bottom. And there we go. So now I have my 3-dimensional shape and I have my net. Right? So let's take a look at a couple more types of figures. The other thing that I want to do is be able to identify what each of these shapes are. So right now I have a figure. It's a 3-dimensional figure right here. And this is a triangular prism. So I have my triangular prism, and I want to describe the base. Now, up until this point in Unit 10, when we talked about solving for area, we used length and width, and not base and height, even though they're interchangeable when you're talking about a 2-dimensional shape. The reason we did that is because now we're talking about the base. We're talking about this shape on the bottom. So you start, what is the base of this figure? Well, this is a straight line across the back. So the base is a triangle. Now, what about the lateral faces? These ones on the side, they're also triangles. So the figure is a triangular prism. And prism is a term that we're going to be using to discuss our 3-dimensional objects, right? Rectangular prisms are like boxes. Triangular prisms, kind of like that. So I've identified my net. I know what all my shapes are. So what are the sides? Well, I have a base, which is a triangle. If I were to lay that triangle open, right? Just picture like a sci-fi movie at a pyramid, just lays open. All of the sides would come off of that base. Now I have a net. I can solve all of those triangles and my base and be able to tell you what it is. There's my triangular prism. On the contrary, if I had a square base, right, then I would have 4 sides to my pyramid. But this one is obviously, instead of a rectangle, I have a triangular base. So I can identify my shape and I lay out the sides. Now, this is, one last one here I want to show you. I have a net that was given for me, and instead of having to picture myself laying it out, I have a net that's laid out for me. I want to identify and sketch the solid figure that can be formed by the net. And this is a little tricky because it takes some practice to be able to draw 3-dimensional shapes, right? So, the net has how many triangles? Well, the top and the bottom, there are 2 triangles. So this can't be a rectangular prism. Like it's not going to work. So the triangles must be the top and the bottom. So I start with the top, and I just draw myself a triangle, right? And off of that triangle, I see if I were to close this, I have a side that is a rectangle, and then I have another side right here that is a rectangle. And on the back then, I also would probably have a rectangle. So I have, let me make that a little straighter. Looks like I had an extra side in there. So what I get now is something that looks very similar to like a Toblerone container, right? It's kind of like a triangle, but it's stretched out. So my sides are small triangles, and then all of my other faces are rectangles. And that really helps me to identify the shape that I'm working with. This is the starting point for our unit with Unit 11. Enabled to solve surface area and volume, we want to be able to identify the shape and then figure out all of the different surfaces that I could solve it with. If I'm looking for surface area here, I need a area equals length times width. There's my front. I have a matching back. So I have that formula. I have the same formula for the spine here, the little piece there. Area equals length times width. And then I need a triangle. Area equals 1/2 length times width, or base times height. Again, we've been using length and width, not base and height, because I don't want to confuse the whole base here with our two-dimensional shapes. Now, with these two formulas that I already know from Unit 10, I'm able to solve for all of the different surface areas and add them together, and then I get the total surface area around. So again, start with the shapes, see how they connect, draw it out in a net.